And you've got so many cool things on your shelf. I feel bad cropping it out. You do. You have a shelf that looks really cool.
I know, I know.
I want a shelf that's really cool. I just have notepads everywhere.
You have to build one over time.
No one sends me
Oh,
anything.
all right, Popo chat. Okay, fine.
Play my chat.
Where's my Popo chat? Okay, there we go. All right, chat, I'm ready.
All right. And
what have you got on the screen there? Is that some kind of space station?
Yeah, that's the spacewalk going on right now.
Oh, I didn't know there was a spacewalk going on right now.
Yeah, it's been going on for a while, I think. But just it also shows the flat Earth, you know?
Well, my dad always used to call them the floaters.
The floaters? Why is that?
Yeah. Like the astronauts. So as you can see the astronauts that are floating around in space, my dad would go, "Oh, the floaters are on TV." and then we would I would watch the astronauts with him.
So your dad was big into space.
Oh yeah. My dad woke me up in 1981 when the space shuttle was first flying, and he had me come and watch the first launch of the space shuttle. And then I actually tried to take my dad to see a shuttle launch because, as a journalist, I get access to be able to do this kind of thing. And so I took my dad with me to Cape Canaveral for the second to last launch of the space shuttle. And there was a big delay. And so we weren't able to see it. And so in the end, we went down, watched the shuttle, and didn't get a chance to see it launch. So that sucked. And then, and so that was going to be my first ever rocket launch, and didn't get a chance to see it. So I tried to pay him back.
Yes.
Didn't work.
Didn't work.
Yeah.
Hello, Fraser. We're saying stayed up all night and it was scrubbed. Someone said that. Daddy Cup, yep, stayed up all night and it was scrubbed. I don't know if they're talking about.
Oh, I don't know which one.
I don't know either.
The one that we'd had, there was a problem with the fuel tank, and so they scrubbed it a couple of times within a couple of days, and we just sort of killed some time in Florida, and then like went down to Miami and checked that out, and then came back, and then it turns out they delayed it for like a whole month, and then everybody else who did that was able to just show up and for the last shuttle launch, and it just went up like a charm, no delay, everything was fine. So that's how rockets work. You're not guaranteed to see your rocket launch. Although we had no problem with OSIRIS-REx, which launched like a charm, which was about 2 years ago.
Yeah,
so that was fun.
Yeah, and well, let's see what I'm trying to just kind of see what chat's saying. The spacewalk just finished. Great stuff. I don't even know what they were doing. I have no idea why that spacewalk was taking place. That sounds terrible as a science communicator. I have no idea. Do you?
No, it's fine. Don't feel bad about it. It's funny. We used to post stories on Universe Today about shuttle or spacewalks, and nobody would read them.
Yeah.
And so I just was like, you know what? I don't need to. I'll tweet a link to the fact that the astronauts are outside right now and they're on a spacewalk. But apart from that, I wouldn't get too worked up about it, except when their helmets fill up with water and they are potentially going to die, and then that's when you get
wait,
pretty big news.
When did that happen?
Happened a couple of years ago with Luca Palmatine. I forget how to pronounce his name. He was doing a spacewalk, and I guess his water system was leaking water into his helmet. And of course, the problem is that when you're in space, you can't get the water away from your face. It just floats around, and so he was at risk of actually asphyxiating on the water. So they had to sort of cut it short, and he had to race inside to get inside the space station and get his helmet off. And so then they actually had to change the design for the astronauts' helmets so that this wouldn't happen again. So yeah, no, it was actually pretty scary.
Oh my goodness. So it was a design flaw?
Well, I mean, it was a hardware failure of the water recycling system, and
so yes.
yeah. I mean, maybe, yeah. So still kind of scary that. I like that. Toxic Calf 420 says, couldn't you just drink all of it? Yeah. That was
No.
the problem. The problem is you can't, like if it's coming down your face and into your nose and you have no way to touch your face because it's in your helmet. No, there's nothing you could really
Yeah,
do.
you can't.
So, yeah, no, it's every time. I mean, you talk to the astronauts, and I'm fortunate that I get a chance to interview them often.
Mm-hmm.
It's a thrill and it's definitely a privilege to be able to go out and walk out in space like that. But they are constantly aware of just how dangerous and hostile the space environment is. So, space is trying to kill you.
Yeah, and this is a great way to start this talk. So what I know from things is what we learned with like Scott Kelly, but like their fingernails, if the pressure in their gloves is too much, they lose fingernails.
Yeah, they all lose their fingernails. They mostly lose their fingernails. All of them. because the gloves are so terrible.
Yeah. So that's one thing I know. And also I know that everybody's like, what? No, we're going to talk about a little bit what astronauts have to go through. A lot of people don't know this kind of stuff. Even though they publish a lot of things with having, the two twins, that was pretty amazing. But yeah, so they lose fingernails if you have, what happened with his twin? What do you mean what happened? Don't they?
Well, so did you read Endurance? Did you read his book?
I did not read that book.
Yeah, it was a great book. One of the best astronaut memoirs that I've read in a long time. And the thing that's really interesting is you really get this sense of how, again, Scott Kelly was quite aware, there's a lot of complaints and issues that he had with the station, right? And the one that he had the biggest problems with was the carbon dioxide scrubber. Both the Americans and the Russians have machines that remove the excess carbon dioxide in the space station's atmosphere. And they are, he could just tell. He could tell when the carbon dioxide levels were just a little too high, and he was constantly battling with this accursed machine to get it to give him clean air. And as soon as it became too high for him, he was getting headaches and he felt lethargic and he just felt like crap. And you can just imagine for astronauts, like if that CO2 scrubber goes down, you die, right?
Yeah.
And but even to just be in the peak of your performance, right? You need to have perfectly low levels of carbon dioxide so that you can just focus and concentrate and get your work done. And so imagine you're having to spend day after day and the carbon dioxide levels are just a couple of percent higher than you want them to be. And you just are in a state the whole time. So there was a lot of, like, they're constantly finding stuff floating around on the station because, nothing falls down on the ground. You can't just vacuum it all up. They're constantly finding old parts and screws and pieces of food and people's missing plastic forks and things like that. So, so RJ Monty is saying this in the chat, right? That Kelly would talk with his wife and he'd get grumpy and she would go, "Oh, the CO2 levels are up." And he would say, "Yes."
And that's a true thing.
Oh yeah. Yeah.
Oh my God.
Yeah. And so you're super attuned to that whole environment when you're up there because, I mean, we're just like, the whole Earth is this gigantic sponge that soaks up the carbon dioxide and pumps out the oxygen, and the water falls and it gets cleaned and all of that, right? And it's this huge machine that's helping to have the best possible environment that you can have to live in because we evolved in it. But with the space station, it's this closed environment, and every little tweak and change that happens to it just comes from technology. Yeah. And you get the technology off just a tiny little bit and you get mild levels of CO2 poisoning, or a meteoroid punches through your space station, or you run out of food, or radiation, solar storm from radiation, or all these different ways, right? Yeah. Every single one of these is
the radiation, how much, I don't know off the top of my head because I just don't right now. I can only remember so many numbers, but how much radiation do they, like, how much
Well, if you're as an astronaut on the International Space Station, you're still protected by the Earth's magnetosphere. So I
Right.
believe they get about 10 times the radiation that you experience down here on Earth. So it's still a much lower radiation environment than deep space. And then I think it's another multiple of 10 if you go out beyond the Van Allen belt. If you go outside of the magnetosphere, then you experience about 10 times more again. So, and if you go down to, say, the surface of Mars, you're kind of in between. It's better than deep space, but because it has this really sort of slight atmosphere,
Right.
but it's still much worse than being within the magnetosphere of the Earth. So,
Yeah.
and Mars has no magnetosphere. So,
Yeah.
and you know, you've got these sort of two main causes, right? Once you get out of the Van Allen belts, which is the trapped radiation, then you've got the galactic cosmic radiation, which is these high energy particles that come out of all directions from the universe. And they're quite deadly over long periods of time. And then you've got these periodic solar storms. And again, those can be deadly. You know, one big powerful solar storm can just can kill you in a day.
Yeah.
If you're in the wrong place at the wrong time.
Yeah. And especially those other stars that we've been looking at, we're like, hey, these red dwarf stars. And then we're like, yikes. Like, yikes. These guys are...
red dwarf star can release a flare that would wipe all life off Earth.
Yeah. And that's the majority of the stars out there. So that's...
Yeah, but
at least
I mean,
we're
the majority
learning.
of the red dwarfs aren't necessarily flare stars.
Right.
They are flare stars sort of early on in their life. And then they settle down over time. It just takes them a few billion years.
Yeah, usually, isn't it with their spin? Like the faster they spin, usually, and that would indicate that they're younger, usually, right?
Yeah, I don't know what the actual sort of, what the time frame is and what causes the stars to settle down. It's a good question.
Yeah, I think they have a pretty significant spin. Where our star, rotates obviously different at the equator versus the poles. I think it's like 25 days at the equator and 29 days at the poles. So like 27, you could say, like if you want to average it out.
Yeah.
But yeah. So wait, stars far away can wipe out life here. No. We were talking about if you wanted to be part of, say, Proxima Centauri system. So Proxima B, we've learned that Proxima Centauri is not a very nice star.
Although astronomers recently did a survey using the Chandra X-ray Observatory, and they scanned the Alpha Centauri A and B, so to see if it gets a lot of flare radiation from Proxima Centauri, and it turns out it doesn't. So if there's planets at Alpha Centauri, they're not harmed by the awful flares coming off of Proxima Centauri. So that's good news. That
is good news because that is a trinary star system, guys. So we've kind of thought that Proxima Centauri was combined with this system, but we hadn't really confirmed it until I think roughly a year. Forgive my timing on this, might be 2 years now. But yeah, then we were like, hey, it actually is a trinary star system. So Proxima Centauri orbits Proxima Centauri orbits Alpha Centauri A and B. And those two stars orbit each other. Right. So very cool system. And that is our closest system.
Now, do you want to throw questions at me? Should I grab questions from your? I'm so used to being the moderator that I
know. Well,
I'm in your capable hands.
Yeah, but we could do a little bit of both. Like that's the thing. I like it to be pretty casual. So if you see a good question here that you want to respond to, well,
the Halion 314 question about how can we battle radiation while exploring the universe based on current technology is a great question.
Go for it.
And there is an answer a little bit further down below. So right now, the plan is you cover your spacecraft with some kind of shielding, thicker materials that can absorb some of the radiation, and then luck. and the inside the Orion spaceship, the new crew capsule that's being developed, they have a bunch of gear in various bags. And I am not kidding you, when there's a solar storm detected, they build a fort inside the capsule out of all of this material, and then they hide inside while they wait for the solar storm to pass. And so they can, they have their water and they have their food and they have various electronics and equipment and things like that, and they can just sort of pile it up around them and then just hold out inside until the storm is over. But obviously that's ridiculous for actual living out in space. I mean, you can't be a belter if you have to build a fort every time you want to handle a solar storm. So the other thing that you do, blanket fort. So obviously the goal here is like, let's build an artificial magnetosphere, the kind of thing that we have here on Earth, right? We're protected by the radiation from our magnetosphere. And so you would think that you could just do something similar. And this is something that NASA and the other space agencies have been trying to do for decades. I mean, clearly this is, like you run a run electric wire, wires carrying electricity, you run them in coils, crank up the juice, and you will get a magnetic field that in theory can help you redirect the particles. But the problem is that the amount of electricity that you require is just enormous. So there's been some really interesting, just sort of different structures that I've seen, and every couple of years you hear another press release from NASA or CERN or the European Space Agency where they've developed a new structure on they're running superconducting coils and they're running electricity through the coils, and this is the way that they're going to be able to potentially create an artificial magnetosphere around a spaceship. But they always just find that when you look at just the total amount of mass required, the energy requirements to run this, it's still just easier to just pile up garbage around you and hang out inside. Water is probably one of the best methods to protect yourself. You get 1 meter under ice, for example, or water, and you'll receive 1/1,000,000th the solar radiation. So all you want to do is have a spaceship that's a big ball of water and then hang out inside the middle of it. And water's got other uses. It's, you like to drink it and you can break it apart and use it for breathing, and you can use it for rocket fuel. So I think in the future, as we get more and more water in space, that will be used as a way of shielding habitats, people, everything.
And someone, well, this is a good question too. So, and I haven't heard about this one, but Eskimo says, is it true that NASA is making robots that can make structures using moon dust?
Well, it's not necessarily that it's NASA that's doing it, but I mean, they're all, so it's this concept of in situ resource acquisition. So essentially living off the land while you're in space. And so why take a habitat to the moon when the moon is made of things that you can make habitats out of? Why take water to the moon when in theory in the permanently shadowed craters on the moon, there is water? So the idea is that you could take like a 3D printer to the moon, have it gather up moon dust, turn it into concrete, and build structures that you would require. And there's been a bunch of people that are doing that. And there was a recent study that said that, yes, indeed, they've demonstrated that you can turn lunar regolith into a building material, and you can do it on the surface. You can have a robot do it. So you can imagine some future robots that go a couple of years before the colonists go, and they just build structures on the surface of the moon, and then the colonists show up and they just move in. And do the same on Mars. So, yeah.
So, and going in line with that, someone's talking about, again, the problem of having no magnetosphere with Mars. So did NASA propose some sort of device that creates a magnetic shield, parking it at the Lagrange point 1?
Yeah.
L1?
Yeah, people know their space news.
I know. I love my community.
The idea, so this was actually proposed by the chief scientist at NASA, and it's a great idea. So the problem, of course, is that Mars has no magnetosphere, and the magnetosphere protects you from radiation. But the thing that the magnetosphere is doing is it's stopping the sun's radiation from blasting particles off the surface of Mars and Earth and out into space. And so that's Mars is so dry because the solar radiation has been slamming it for billions and billions of years.
Yeah.
And so the idea to make Mars habitable again, or more habitable anyway, is you set up a big shield in the L1 Sun Mars Lagrange point, which is this sort of perfect balance point between it's not halfway in between, but it's sort of a balanced point where you don't need a lot of energy to maintain your orbit. And it will sort of, and you can kind of imagine it like a rock that you put in a river. And then behind that, you've got this sort of calm area behind it. And so you'd have this cone behind this shield where no radiation would be reaching Mars. And the amazing thing about that is once you did that, then just the natural volcanic gases that are emanating on Mars would start to warm up the planet, and you get a couple more degrees, and you're going to get the ice caps to actually start to melt, and the atmosphere is going to thicken even more, and you could actually make the planet blue again just by setting up this shield. But of course, setting up a gigantic shield, holding it in the L1 Lagrange point for hundreds of thousands of years is a very complicated effort. Yes. So if you really want to live on Mars and you want to make it safer, then totally build this shield. But the problem, of course, is that only protects you from the solar radiation, doesn't protect you from the galactic cosmic radiation, which is coming from everywhere and will increase your cancer risk. So there are other ideas to do that as well.
Sorry. Your mic is adjusting. So is it on auto adjust for you? Like your mic volume? Does it do that?
Maybe. I don't know.
I don't know if Zoom does that.
It shouldn't normally, but maybe Zoom is doing it.
Yeah, I think Zoom's doing it. Weird.
Yeah.
Okay, it's fine. I can manually control that, but I might have to go tell someone downstairs that they're on a phone call and I'm trying to tell them, so I might have to step away. But you can answer questions because I need to just tell them that it's echoing. Problem. And I'm in a room that gets really, really hot, so I have to keep the door open, or else I will die. I will melt.
I can't hear anything, so if there's like some kind of construction noise going on or something, I can't hear it.
Oh, see, and your mic level just adjusted again, but that's okay. You're fine.
It's not me. It might be me. I don't know. Windows.
Who knows? We'll just say it's Zoom. But I'll be right back. So,
all right,
you got the questions.
Yeah. Glad to. Midnight Q is asking what time frame would that realistically to put up that shield? It would be really, really complicated, right? It would be bigger than the biggest space telescope that's ever been built. You'd have to fire it out to the L1 Lagrange point, which would take a lot of energy. You'd have to unfurl it and you'd have to keep it in place. And that would just be an enormous amount of work. Star Stuff Studios, in light of the fantastic decision to fund WFIRST by the Senate, can you elaborate on what WFIRST is going to do? Sure. So WFIRST, the Wide Field Infrared Telescope, is this new telescope that's going to be going into space probably by the mid-2020s. And this is actually a leftover telescope from the Air Force's National Reconnaissance Office. They gave NASA 2 of these telescopes that are as good as Hubble. And they were originally, I guess, designed to look at the ground, to, watch you from above. And then the NRO said, well, these telescopes are as big as Hubble, but we don't need them anymore. So you can have them, NASA. And so NASA took one of these telescopes and is turning it into WFIRST. And so it's going to be this wide field infrared telescope. And so wide field is really important because it lets you see a large portion of the sky. Well, Hubble is like seeing, I forget exactly what it is like. It's like seeing a dime many meters away. WFIRST is going to see this really wide view of the sky, but it's going to be an infrared telescope, the kind of telescope like what James Webb is going to be, like what the Spitzer Space Telescope is going to be. And so it's going to be the kind of thing that's going to be able to see cooler objects, things like planet-forming regions, the sort of high redshifted regions of space. It's going to be able to see asteroids, things like that. Dragon Nation is wondering, what is the core of Mars made of? We don't know. It's it's probably like Earth, but Mars cooled off a long time ago. And so it doesn't have the same kind of, it definitely doesn't have a rotating metal core. It doesn't have, a magma in the same way because Mars is just so much smaller. It cooled off. But NASA's InSight lander is going to Mars right now. And one of the things that it's going to be able to do is it's going to land on the surface of Mars, and then it's just going to listen really carefully to what's going on Mars. And it's going to theoretically be able to hear tiny earthquakes as they move through Mars, and it'll use those earthquakes to map out what's inside Mars. And so this is the exact question that the Mars InSight lander is going to be going to try and answer right now. And so we should find out with a lot more accuracy. In fact, this spacecraft is going to be able to detect like meteorites striking the surface within some distance of the lander. So it's a very, very sensitive instrument. So this is, planetary scientists had this exact same question, and now this is the spacecraft to find out the answer to it.
What are we talking about? InSight?
Yeah, I was just talking about InSight.
Oh yeah, InSight's pretty cool.
Yeah, and it's sort of an amazing story just to sort of hear what kind of scientific instruments they're sending, right? It's going to have this seismometer, but in this vacuum chamber, and it's like one of, this technology has been worked out here on Earth, but you can always tinker with it and you can always sort of fix it if there's a problem. And so they had to build this incredibly sensitive seismometer and then send it to Mars, which is a gigantic challenge. So when they first built it, it was leaking, but it took over the course of like a year to leak out some of the vacuum, or leak some of the vacuum in. And so but that would be enough to muddy the readings as the atmosphere of Mars was slowly leaking into the vacuum chamber where the seismometer is. So they had to rebuild the whole thing to make it work again. So
what's happening right now with Opie with?
Oh no, yeah.
I know.
Yeah.
I wanted to wait to have that talk with you because you know more about it. I mean, I was watching some of the conferences and stuff about it, but you know more probably because you probably have been really immersed with that. I had to break up my day.
Yeah, I mean, sort of semi-immersed. And we talked about it on the Weekly Space Hangout last night. So the Opportunity rover is under a gigantic dust storm right now, and it is bad. It is probably the worst dust storm that has ever been seen on the surface of Mars in modern history. Like, since we've been able to measure the strength of these dust storms, this is the worst one. And it is, half of Mars right now. I think it just enveloped Curiosity. It's already enveloped Opportunity. And in the past, we've seen these dust storms take over the entire planet, and then they last several weeks. And so Opportunity happened to get caught, and Opportunity has solar panels. And so it has to, refill its solar energy, and it needs to have the sunlight to be able to do it. And so this dust storm has made it really black as night where Opportunity is. There is, before, I think it gets a couple of 100 watts of energy onto its solar panels. Now it's down to 2 milliwatts of power. So it's really getting no energy whatsoever. And obviously, it can't do any science, but the problem is that Opportunity needs to keep itself warm, or else its instruments and its battery system will break down and the rover will die. And so in order to keep itself warm, it actually has 8 pellets of decaying radioactive material on board, and these are just constantly putting out heat, and that sort of does most of the heavy lifting to keep it warm. But then it's got heaters that help it through some of these colder times. And so the battery system, again, for the almost 15 years that it's been going now, 5,000 days on Mars, I think the battery system is down to 85% now, but it has to, that, and it's sort of like right in the danger zone of whether or not it has enough energy and enough energy stored up to be able to keep itself warm. It has to stay above minus 20 Celsius or it starts to die. So right now NASA seems pretty hopeful, but this is the kind of event that killed Spirit. So Spirit went through a really cold time and it wasn't able to make it out the other side. And so it's entirely possible that this is when we say goodbye to opportunity. But I really
When will
hope
we
that
know for sure?
Well, we won't know until the storm is over and it gains enough power and it's able to communicate again.
And
so,
and it's been lingering for a bit, yeah?
Well, it's in, you know, right now they're not able to talk to it. They were able to talk to it just before the storm really set in. And then now it's just, you know, it has to follow its training, follow its programming to be able to survive through this. So yeah, it's a rough time.
And it's got pretty decent batteries on it.
Yeah, well, and as I said, the batteries are 85%. So when you think about the fact that it's been going day, night, winter, summer for years and years and years, 5,000 plus days, the batteries have been charging and discharging and recharging. It's only down to 85%. So that's not bad, right?
Right.
But it could be bad enough to mean that it isn't able to recover from this. Because if it stays colder than -20, then it's done. And it needs 0 degrees to recharge its batteries. So
yeah, let's see. Mars is tilted, but I don't remember how much.
Almost the same. Almost the same.
Earth. Yeah. Very, very close to the same.
So it goes through seasons in the same way. In fact, we're just exiting the winter in the northern hemisphere on Mars, and I shared a really great picture on my Twitter about half a week ago, where there's these last little frosty touches of snow in the craters in the northern hemisphere, that's for the carbon dioxide, and then those carbon dioxide the poles return every wintertime. But so it's summertime or nearing summertime for the northern hemisphere of Mars.
And I'm sorry, I'm looking at the Zoom settings real quick too. Let's see. So I take those batteries over a day. We got cheap stuff here. Well, yeah. So that's with intention though. That's with intention.
Yeah, I mean the solar panels and the batteries. I mean, this is one of the things that NASA has contributed to is solar panel technology, battery technology. These are the kinds of things that we enjoy. Some of this technology has made its way into what we use every day.
Oh, I found it.
They are very carefully looking through, watching those batteries, and they know exactly how to recharge them and when to let it recharge and how to charge it back down. So they're taking really good care of those batteries. Again, 14 years, like they were only supposed to be there for 90 days. So even if Opportunity dies, it was a valiant little rover.
Yes. And I have to show you this too real quick. If you look, well, you might not be able to see, well, if you might be able to see it.
I can see what's happening on the screen. I haven't muted, so
I found this in the settings. Right here, it does automatically adjust. This was auto-clicked right here. That's what's happening. This was defaulted to on, so it's that way for you right now.
Is it?
Uh-huh. So it's auto-adjusting.
Is that's on Zoom?
Yeah, it's the settings.
And so you can see my Zoom settings?
No, it was on for me.
Oh, okay.
And so it must be on for you because right now I'm trying to do DJ Sky and adjust the volumes, levels.
You're right.
Yeah.
There.
How evil.
Yeah, that's pretty fiendish.
I know. Okay. Well, that's good. We got that. We're good now. Now I can actually adjust the levels and say we're good.
Yeah. Well, and who knows if this was ever happening before, because
it was.
I'm always recording locally. I'm always the one, like you, I'm the one who's doing all the recording. So I don't have to think about the volume of my audio, but
yeah. I've noticed it with Dr. Pamela before, but she also has a wonky cable too. So I never know if it's the cable connecting to her mic or, but yeah, Zoom is great. Zoom is actually really nice. So let's see. I wish my remote batteries would last for 14 years. Yeah. It's pretty cool. So
you should take better care of them, pull them out, charge them up, and then when you don't fully charge them and then don't fully discharge them, you can make your batteries last a little longer. And same thing with your smartphone. There's tips and tricks you can use to make your smartphone batteries last longer.
Yeah. Joe had a good question. So he said, you know, if there's a very, very thin atmosphere on Mars, you know, not much wind is what they portrayed in, let's say, The Martian. What causes these kind of dust storms? Like, how can they get so...
The gravity on Mars is low, and the actual amount of the wind speeds can actually get quite high. They can get, you know, hurricane speed winds on Mars. And so it's the same thing as you get on Earth. You have temperature differences from one location to another location, and the temperature changes can be vast. You know, you can have room temperature one day, and then you can have 100+ degrees below zero the next day. And so you're going to get these big temperature differences. And so you're going to get winds, and the wind speeds can get up very, very high. The trick is that the actual wind strength is very low because the density of the atmosphere is 1% of what it is here on Earth. So you get high wind speeds, but you couldn't even fly a kite in them. But they can pick up, but it's enough to pick up the dust.
The dust.
And that can throw the dust around and make it tough to be able to see or, you know, refill your solar panels. And it just shows you this is another way that space is trying to kill you. This is the theme, is space wants you dead. And
that's the theme, you know, of all science communication.
All of it. Yeah, I just keep coming back to that.
And so War Against Rights, so he's kind of moving on to one of the other things that was in the news. I'm sure you read about the gamma ray burst with the neutron stars. I mean, I wanted to wait for that one too. I read that this morning earlier.
So hold on. So what was the story? So
it's this right here. So the gamma ray burst that they're seeing, right here, the gamma ray signal that's usually, it was unusually faint and short for a GRB, afterglow brightness at frequencies. I know that it was because it was actually at a certain angle. I think it was like 30 degrees.
Oh, interesting. Okay.
And they said that it actually increased in its brightness. And it's
so one of the weird things, this is the kilonova event, right, that happened in 2017, where you had two neutron stars collide into each other, and astronomers saw gravitational waves and electromagnetic radiation coming at the same time, which proved all this stuff about Einstein and so on. And also helped understand that, you know, some of the heavier elements that we see in the universe seem to come from these colliding neutron stars. And one of the thoughts for these other things, these gamma ray bursts, is that they come from colliding neutron stars. And so I'm guessing, and one of the weird things about the kilonova, normally short period gamma ray bursts, they flash up and then they fade very quickly and then they disappear. But for some reason, the kilonova was brightening and brightening and brightening, and actually only started to dim a couple of months ago, which was a bit of a surprise for astronomers and something they were having trouble explaining. So I haven't seen this news, but so they're saying that that we're seeing it at a 30-degree angle.
Yes,
and that's why it had this weird profile over time.
Yes. Sorry, I have a funny, like a sound that comes through when someone makes a donation, and that
I didn't hear it. Well, that's because I've got it muted.
Yeah, so. No, that's okay.
Yeah.
They said in their donation, hello, sorry, I do not understand too much English. I'm French, but I wanted to know what software you're using in the background. This is called Space Engine.
Yes.
Thank you for that
All
donation
hail Space
too.
Engine.
Yes, space. There, right there is the link. And yes, thank you so much for that. It scares me because it's loud, but it's good because it's funny. The notification.
Oh, that's a good one. AstroBob65 is asking, any comments on the paper that speculates that no alien life in the observable universe?
Yeah. So I'm looking at that one too.
Did you see that? Yeah.
I think where was it? Where was that one? I'm not looking at my start inbox.
On my Twitter, maybe?
It might have been. No. Is it? Well, it's not the study could help humans colonize Mars. No, that's not it. And hunt for alien life.
So this was a.
I'm going to your Twitter now.
Do you want this through? Here, I'll put the link. Although it's a paper, so I'll just put it into the Twitch chat.
Ooh.
So the paper's called "Dissolving the Fermi Paradox." And the gist of the paper is that they essentially reran the Drake equation with what they thought was better math, and based on what they come to the likelihood is that we are the only advanced civilization in the entire observable universe, which explains why we don't see any aliens, right?
Wait, is it this one that you posted 19 hours ago saying one way to find aliens would be to search for artificial rings? No.
Nope. I
want the link to the tweet that you had.
I put it's up on your screen right now.
The paper.
The Dissolving the Fermi. We haven't written an article on it yet.
Oh, okay.
That's how. So here's what I do is I post links to stories that I'm thinking about writing, or sending off to our, having our team work on, and then I wait and see sort of if people are interested, and if they are, then we'll actually write an article. So often you'll see a tweet and the actual article, 6 hours delayed.
Yeah, and
Twitter.
People would be interested in this.
Of course, but you never know. You have to test.
Just like the wormhole. How did that go?
Yeah, I'm not touching that with a 10-foot pole.
Did you make Dr. Paul talk about it last night?
Nope.
No.
No. Yeah, well, there is this, and I'm sure this has happened to you too, right? The more time you spend in this world, the less that super speculative high-end physics is to you, because wormholes, white holes, all that stuff, warp drives, it's probably not real, and it's probably not going to ever work. And you get more and more interested in the nuance of the kinds of discoveries that are getting made. I'm really fascinated by the fact that they've figured out that globular clusters are 4 billion years younger than they had previously believed, or new methods of calculating variable stars, or new technologies for trying to create a magnetosphere around a spacecraft, or all that kind of ways to make buildings out of lunar regolith on the moon. So as you spend more time in this, like, I'm sure people, and I would love to hear from your chat, right? A person will show up and they're like, tell me about wormholes.
Yes.
And then, a year later, if that person is still kicking around and has sort of gained more knowledge, they're not interested in wormholes, because, I don't know, it's just like, here's one little tweak of the math that brings you sci-fi Christmas.
Mm-hmm.
And when sci-fi Christmas never shows up, you are more interested in the things that just seem to be actually possible. So that's why I think it feels like that happened to me, and you can see with a lot of other people too. They're just like, they start out and they're just like, I just want to know about all the stuff that's going to make Star Trek real.
I know. And warp drive. And I want to know, like, why can't we bend and fold space time?
Yeah, where's my Stargate?
Yeah, and
right?
I'm always like, I don't know what to do with that. I don't know what to tell you. But and then so I kill Christmas all the time on here.
Yeah, all the time too. Yep.
Yeah,
and it is this journey that we all must make, where we start out believing in the Tooth Fairy and Santa Claus, and eventually, you just kind of get a little more realistic, I guess. And then get fascinated by the real nuances of what's going on. And that's what I hope, is that, you come to this place where you are excited about the incremental advances in the new technology. And then these gigantic things do come along, like SpaceX landing rockets again,
mm-hmm.
And you're just like, that is a dramatic improvement over what we have to date. And so, and yet in sci-fi, you land a rocket, take off a rocket from a planet, that's totally normal. It's boring. But the reality is that's mind-bending that they're able to, launch a rocket, parts of the rocket come back to Earth, land. I love it.
Yeah, and how they landed that one that we all saw that was really, really cool, the Falcon Heavy.
Yeah. And when the BFR, if the BFR does show up, right, it is a single stage to orbit rocket on its own. It's going to take off. It's going to go to orbit. Both halves are going to return to the Earth and land safely. You could take the BFR to the moon, land on the moon, walk around, pick up a bunch of lunar spacecraft, and then just get back on your spacecraft and come home, and like out of the box. Like the BFR is ready to do that. So for all of the skeptical side of it as well, you've got these really cool advances that are coming up. And I just did a video about the next generation telescopes that are coming, the HabEx and the Lynx and the LUVOIR, right? The LUVOIR is going to be a 15-meter telescope if it happens, which is just, it's crazy, bigger than the biggest telescope on Earth, but it's going to be in space. So
I haven't even heard about that one.
You should watch my videos.
I know.
Yeah.
We'll probably do that after this too, because that's usually
so
what we
LUVOIR,
do.
this is the telescope that they're going to be building after. So James Webb, and then WFIRST, and then there's 4 other telescopes that NASA is considering for their
and WFIRST got saved, right?
Yeah, WFIRST has been saved for now, but it could be canceled again, right? And then there's HabEx, which is the Habitable Worlds Explorer, so it's going to be able to directly image the atmospheres of Earth-sized worlds around other stars. There's Lynx, which is going to be this really powerful X-ray telescope that's going to push out to the edge of the observable universe like James Webb. There's the Origin Space Telescope, which is going to go farther than James Webb. So it's going to see right to the first stars forming just right after the cosmic microwave background. And then there's LUVOIR, which is so it's the Large Ultraviolet Optical Infrared Observatory. And so it is the successor to the Hubble Space Telescope. And it's going to be this huge folding 15-meter mirror, right? So imagine, I don't know, you know how you take the Hubble Space Telescope and then you put 7 of them, and then that's James Webb. And so if you take like a bunch of James Webbs, that'll be LUVOIR, right? And so it will do just astonishing things, but it's going to take new technology to be able to put it up. And we're not going to see it till like 2035. So,
and wait, you said,
and probably later.
I'm going to have you run through the acronym again.
LUVOIR, the Large Ultraviolet Infrared Observatory. Large
Ultraviolet
Yeah,
Infrared.
LUVOIR, LUVOIR. Yeah, optical.
Oh, there it is. Holy crap.
Yeah.
Wow.
So that's what's coming next. And this is sort of this whole idea, NASA has this thing called the decadal survey. So every 10 years, all of the space scientists come together and they make the recommendations to NASA for what missions they want as their next sort of what big scientific questions that they need answered. And then NASA goes and does these plans for these different instruments. And every telescope that you know of used to be part of this, went through this decadal survey. So the Spitzer Space Telescope and Chandra and James Webb and Hubble and all of these go through this process. And so now the next decadal survey is about to begin. Pamela was on the board, was part of the process last time. And will probably be part of the process again this time. So definitely talk to her about the decadal survey.
Oh my goodness!
It's like the Olympics of space policy.
Yeah,
every 10 years.
Every 10 years,
all these astronomers come together and they make a wish list, and then NASA gets to work trying to build these telescopes to match their requirements.
So out of all of those ones that you said, how many do you think just will actually come to fruition?
Well, I think they'll all eventually get built.
Okay.
Right.
I hope.
Well, yeah, but I mean, it's like.
Well, I guess getting built and then actually doing what we intend them to do. Right.
No, I think they will all eventually get built.
So you're optimistic about James Webb?
Oh, I'm super optimistic about James Webb, in that James Webb is built and is in the shake tests, and there are definitely some troubling delays that are going on, but there's no way they're canceling James Webb. They're going to keep mucking with it. I mean, it's done, it's built, it's ready to go. It's just that last time they shook it up, a bunch of screws and washers came loose.
Yeah.
So that's not good.
That's not good. That's not good
but
at all.
They'll it's like it's a piece of IKEA furniture. They'll find it, they'll put them back in.
It's like Legos, adult Legos.
They'll glue them. Yeah, it's exactly. It's like when you build Lego and you got all these pieces left over, and you have to decide, like, do I care? Am I really going to take it apart and make them fit? Nah, I won't bother. So yeah, I think James Webb is going to launch. WFIRST, I don't know. Right now, NASA is actually getting really good budgets from Congress. They've been getting surprisingly good budgets, even though the White House administration has been trying to cancel NASA's budgets or parts of the budgets. Congress has been overturning that and giving them more money than they've really ever seen in modern memory. So it's a good time for NASA right now. And then what's going to happen into the future, right? After WFIRST, and WFIRST is, just a few billions, while LUVOIR potentially is a $15 billion telescope. Like, so it's planned to be double the price of James Webb. While the other telescopes are going to be in the sort of $3 to $5 billion range. So I think they will all eventually get launched. I think they will just all be far more expensive than anyone ever planned. They're going to take longer than anyone anticipated, and they're going to run into their issues along the way, just like they all do. But,
yeah,
you go back and you talk to the scientists, and you're like, what do you want to know? And they're like, we really need to know if there is, habitable atmospheres on other exoplanets. And so there's only so many times you can keep kicking that can down the road until you build the telescope that will actually find out.
And aren't we kind of close to hearing from Tess some of the
Yeah, well, there was one picture that was already put out. But the thing with TESS, right, is to find its data, it's going to need to take some time. It's going to spend a month at a time observing each chunk of the sky, and then it's going to turn to a different chunk of the sky and slowly map out and search for the telltale signs of planets. But it takes a while to get any kind of confirmation that those planets are there. So it's really this, people describe TESS as the finder scope for the James Webb Space Telescope. It's actually a very low budget mission. Like, I forget what the price, the total price was just $200 million, I think, $300 million. So it's a very inexpensive telescope. The size of the cameras on board are not that big. Its job is to just know if there are planets there, and then other observatories are going to follow up. While the HabX will look at another planet around another star and observe the atmosphere of that planet, right? Like, it's just a whole other level of what's going to be coming.
And are they doing that like using like a coronagraph? Like what technique?
Yeah, they're going to have two coronagraphs for the HabX. So it's going to have a built-in coronagraph like a lot of the ground-based telescopes do. This is like essentially you take this black dot.
Yeah.
And you put it, and you line it up perfectly right in front of the star, and that darkens the star, and then you see fainter objects that are around the star. That's not exactly how it works. And, there's all kinds of interference patterns and waves and deformable mirrors and post-processing things that you do. But that's the gist of it, is you block out the sun, and you get then you get to see the dimmer objects that are around it. I actually took a picture. I don't know if you saw this on my... I'll dig up this picture just because I made my own coronagraph. But the other way is to use a Starshade, and this is where you take you fly another spacecraft that looks like a big sort of flower petal, and you fly it about 10,000 kilometers away from your spacecraft. You perfectly line it up so that this big flower petal is right in front of the star, and then the planets are revealed around it. So and probably Habex is going to use both of those. But the great thing about these coronagraphs is like any telescope can use them. Same thing with the Starshade. You know, you could launch a Starshade tomorrow, and Hubble could use it to find planets, to directly image them. So
yeah, and the Starshades look super cool. I love looking at those. They do look very, very cool.
So I don't know if you can see. So here's my coronagraph. Is that working?
Yeah, it is. Can you put it closer? It is auto-focusing a bit, but
yeah.
It's a flower.
Yeah. So there was a really cool ring around the sun, and so I put a flower in front of the sun.
That is super cool.
Yeah.
Wow.
So that's how a coronagraph works.
Yeah, and I'm trying to get, so I showed them a image of that. This would be the Starshade though. This is different.
There's a great video of the Starshade sort of unraveling and the you can see, I don't know if you've got the original video. There's like a YouTube video. There's a ton out there. Yeah, and you can see the Starshade sort of spinning out and forming and then positioning itself away from the telescope. So
yeah, that's going to be one to watch too. RIP camera sensor.
Yeah.
Let's see. Didn't they intend to link a series of telescopes here in Earth to make one large one that has an eye on one part of the sky?
Well, the method that they've used is the Event Horizon Telescope, and this is where the Worldwide Telescope is this big collection of radio telescopes that are across the whole planet. Mm-hmm. And so they sort of line up all of these radio telescopes, and then they use interferometry to be able to combine the data that all of these radio telescopes are doing to essentially turn the entire Earth into one big telescope. But the problem is that only works in the radio spectrum. It doesn't work so well in other
lower frequency,
in other wavelengths.
Yeah.
So
super big sunflower, I know. And actually, Shift brought up one of the other articles I was going to talk to you about, which came out today. I can bring it up again. The Astronomers, we were talking about this right before, I was going to talk to you about it too, but I wanted to read it with everybody else. So Astronomers see a distant eruption as a black hole destroys a star. Mm-hmm. Did you read this one already?
I have not.
This one was pretty recent. I'd say it got into my email right before I started the stream.
Right. Cool.
Yeah.
I mean, we even see this happening from the supermassive black hole that's at the heart of the Milky Way. So you'll see even blobs of gas and dust go into the supermassive black hole, and you get this blast of gamma radiation as the material is destroyed. But obviously, quasars, these are actually the actively feeding hearts of supermassive black holes. Mm-hmm. And so as a black hole is gobbling down stars, you get this big accretion disk of material around the black hole. You get these crazy magnetic fields that twist around it, and you get these jets that blast out into space. And so we can see when these jets are pointed at us, they become some of the brightest objects in space. So
yeah, it looks like this one. I sent you the article in Discord just in case you wanted to not have to look at my screen and try to defer any kind of information with the small text. But it says the black hole was about 20 million times more massive than the sun. So, our supermassive black hole is 4.3 million solar masses. Yep. This one's
so about 5 times
million.
as big as ours.
Yeah, this is 20 million. And it shredded a star that was twice the sun's mass. So yeah. So it was a pretty violent encounter.
Yeah, and I wonder, this is great. I hadn't, this clearly just came out, and I haven't even had a chance to digest this yet. So this is very cool. I mean, this is the kind of thing that you see, but to see the black hole gobble up this star over a relatively quick period of time. I mean, one of the questions, right, as stars and other material goes into the black hole, mm-hmm. the black hole can't eat them up in one bite.
Right.
Unless the black hole is really big and the star is very small. But even so, what usually happens is the star gets torn up into this accretion disk around the black hole, and then the material falls into it. And so the question is just like, how long does this take? What are the what happens to these stars? How long do they remain? An analogy that I always like to think about is, when you have a bath and you pull the drain on your bathtub, and the water doesn't just suddenly swoosh out the bathtub.
Right.
It starts to spin, and because there's just too much water to go down the drain quickly.
Yeah.
And so that's why you get this big spinning disk around a black hole, because the black holes can't eat this material fast enough. It tries, right? And it will eat it all. It's all doomed.
Yep.
But the black hole can't eat it fast enough. And so you get this period where it's pulling this material down, and some of it is able to escape then. It's quite amazing, actually. In the accretion disk around one of these black holes, you're going to get material that is essentially like the fusion of a star.
So you actually do get that. You get fusion. You get fusion.
Yeah, you get nuclear fusion, and this is one of the things that contributes to how bright the material is coming off of this accretion disk, is the fact that it's fusion. So
yeah, and it looks like they observed it with the VLBA, so the Very Long Baseline Array.
Right, so that'd be a radio telescope.
Yep. So in a pair of colliding galaxies, and these galaxies are about 150 million light years away from Earth.
Right.
So,
and this is something that, this happens a lot when galaxies collide. They feed each other's black holes.
Yes, and that's going to happen with us with Andromeda in, under 5 billion years from now.
Yeah.
But they
although now, who
bigger.
knows? Every day it seems like the Milky Way is getting bigger and more massive than we ever thought. And Andromeda. So now we're almost reaching parity with Andromeda, apparently.
Yeah. Now it's because before I always make jokes saying, that the Milky Way is definitely not as massive, therefore not going to win the mass wars. But
yeah, not so much.
Not so much.
Take that, Andromeda.
Yeah, especially just give it more time, a few billion years.
Yeah.
That's. Let's see. No worries. Black holes are on a Hawking radiation diet.
Yeah. W. Lohadi says, I love how scientific things are named very big, very long, very large, and so on. Have you seen there's an XKCD comic about the names of future telescopes?
No.
Oh, it's awesome. Yeah. Because the ones that are in the works right now is things like the overwhelmingly large telescope.
The super ginormous telescope.
Yeah. So hold on, let me just get some of the names here. So XKCD, they've got the very large telescope is the first one, and then there's the extremely large telescope, which is the next one, and then you've got the overwhelmingly large telescope, and then the oppressively colossal telescope, and the mind-numbingly vast telescope, and the despair telescope, and the cataclysmic telescope, telescope of devastation, the nightmare scope, the infinite telescope, and the final telescope.
That seems about right.
Seems about right. Yeah,
that seems about right. We're pretty awkward at our naming in that we make it very literal.
Yeah, well, it's the European Southern Observatory's telescopes take on these names, so it's the one group, and I think it's just hilarious.
Yeah, I feel like that fits in also with things, like astronomical objects as well, like a supermassive
overwhelmingly
black hole.
large telescope. That's a real telescope name.
Yeah.
Right. So.
The Infinity +1 telescope.
Yeah.
The Nightmare telescope.
Yeah, that's in the list, but that's from XKCD. So
yeah,
it's the final telescope. Yeah.
Yep.
Not a number telescope.
Not a number.
Yeah. So those aren't all real. The first 3 were real names. The first 2 are real telescopes that are in operation, and then the rest are all made up by Randall.
Yeah. And what was some other things I'm looking at here? So they're starting to talk about dark matter.
Who's the they?
Paris. So it says no need for dark matter to explain dynamics of dwarf galaxies.
Yeah, that's a Paul question.
Yeah, no, I know that's not even me. I would not even touch that. I mean, I'll read it, but
just save them up.
Yeah,
where are you getting this from?
This would be the AAS.
Oh, okay. Yeah.
Rick.
Yeah.
Yeah, a new experiment to understand dark matter. That's another one. Oh goodness, these are definitely Paul related. I need to be able to move these to a Paul folder.
Well, they'll be out of. Well, I mean, right now the AAS meeting is going on, and so whenever the AAS meeting is happening, news is sort of fountaining out.
Well, they also have the asteroid day. that everybody I know is super excited about, which is in Luxembourg.
Mm-hmm. As long as the asteroids stay far away.
Wait.
Exciting.
It's not. I was just listening. Oh, it's all over the world. That's what they were trying to show there. So they just list off a bunch of places. I didn't know there's an asteroid day. Did you?
Happy Asteroid Day. Yeah, I got a email from someone asking me to celebrate it.
Yeah. And you know, a lot of people ask me with asteroid questions. They'll be like, "Hey Sky, did you hear about that asteroid that they just discovered that got really, really close to us? Why didn't we see it?"
Yeah.
Because they're dark.
Well, so I mean, on about a week and a half ago, they actually found one that was at about the orbit of about the orbit of the moon, and then it crashed into the Earth and exploded over Botswana. So they actually did detect it. They detected it several hours before it impacted the Earth, and they sent out an alert to all of the astronomers who would be watching for this kind of thing. And you know, in the end, they calculated that it actually wasn't that big of a problem, and so they didn't send any big warnings. But in theory, if there was a bigger impact that was going to be coming, they would have been able to warn the people in the area, and you know, with their cell phones and stuff, and maybe they could have taken some kind of preventative matters. With the Chelyabinsk impact that hit Russia, you know, back in 2013, it came from the sun. It came from the direction of the sun, and so you just didn't see it.
Yeah. And a lot of these that we discover after the fact, because everybody's like, it got so close. How did we not see it? Some of them are dark. They're not going to reflect light. Yeah. And so we can't detect them. It's different if you can't see them.
Yeah. So the need is that you need to put a spacecraft, you know, closer to the sun, probably at the L1 Lagrange point, and then track the movements of the asteroids in the, you know, which would normally be in the blind spot of Earth. So that is that there's a couple of cameras that are in the works. One NeoCam, I think, is in the works, and that's their idea. Is they're going to launch a camera, an automated camera, to the L1 Lagrange point, and then use that to track, and that would give you even more warning, right? Yeah, you get a couple of days of warning when an asteroid is coming in. For Fenring H asks, any news on the Kilopower project? No news, but I just did, you know, the episode before the episode about the super space telescopes that I did was all about Kilopower and fission reactors and, you know, solar panels in space and things like that. So, you know,
we're going to have to do that. We're going to have to have
15 minutes talking about that.
Yeah, we're going to be watching some of these after. And then, you know, of course, with my amazing pauses. That's
where you always stop and get my face in some kind of awkward pause.
It's okay. I do it to myself too, so it's all fair.
You do it to everybody.
I do it to everybody. It's wonderful.
It's super easy.
It is. Yeah. Let's see. So, no, someone said somebody else that was really interesting. Oh yeah, if a black hole star spinning like if a black hole is cannibalizing, I'm going to just fill that in, Mossborg, if you don't mind. Unless I'm completely botching your question, then you can yell at me. So if a black hole is eating a star that's and it spins like draining water, why does it spin in a specific direction? Water spins differently on the northern and southern hemispheres. It does not, and it does not spin at all at the equator. And it's not an or.
Well, so why does anything spin in space in any direction? Right. Mm-hmm. And so the reason why does the solar system spin in the direction that it's spinning? And it all just comes down to the average angular momentum of all of the particles that were in the solar nebula before it all formed. And so if you imagine, you know, the big solar nebula, and every single particle had some kind of random motion that it was jiggling around inside the solar nebula, but as you mash it all together, you're averaging out all of this random motion, and you're getting one sort of final motion that it's doing, and that's the direction that it's spinning. So, you know, it's like if you smash, I don't know, you want things that stick together. So if you smash two cars together, they will spin in a way that is the average of their two motions, right? And so that's why the solar system really, we are the, if you took, if you could calculate the motion of every single particle in the entire solar nebula and did the math, the rotation of the solar system would be the leftover if you averaged it all out. So, and then the same thing with a black hole, right? A black hole is just, it is the average motion of all of the material that formed it and that has gone into it ever since. You could stop a black hole if you fed it. If you could stop it from spinning, if you just kept dropping material in the opposite direction, you could slow it down and then stop it. So,
yeah. And I know you did post something on this. This is kind of a different article, but again, like I know that you actually did tweet about this one. I think I retweeted your tweet on it. Because again, guys, I would follow him on Twitter. Like if you want like space briefings and stuff, I use him as a resource.
What you're seeing, I mean, when you do follow me on Twitter, what you're essentially seeing is my thought process on what stories I want us to cover on the universe today. So, so that's what you're sort of seeing is the stuff that I think is interesting enough that we can report on it. And then, we may end up a couple of hours later actually reporting on it if people are digging it.
Do you remember this one? Because you did talk about this or write about this.
We haven't actually we haven't reported on this one. I don't think we will. As weird as it sounds, right? Astronomers have found a bunch of newborn planets in, and a new technique to be able to find them, and it's really cool. I mean, to be able to find planets that are forming this quickly after a star has formed is pretty fascinating. But we're probably not going to report on it.
But you did. It's the 3 planets found around a brand new star.
I know. I tweeted it.
You tweeted it. Okay.
Yeah.
You're right. Yeah, you didn't actually.
I don't know whether we will actually report on it. So, my gut tells me that it's probably, I mean, it's tough these days to actually be a journalist when the underlying material that's coming from the news providers is so good, right? Like, what could I do?
How could I take this article?
Yeah, what could I do except regurgitate a press release? Well, right? Like, how is that providing any value?
It's true, because it is some of these, they're actually doing a very good job at making so the layman can understand. Yeah.
Nice pictures. They've got the pictures. They've got access to the astronomers who are doing the research. So it's, NASA is my best competitor.
Yes.
Because they're the ones who's actually, they have access to the spacecraft and the space stations and the astronauts and the space scientists and the pictures. And, the astronauts are taking the pictures from space for them. And then we all can retweet it. But so a lot of the times I look at this and say, you know what? ESO has done a pretty good job of reporting this information. So I'm just going to link to their press release and move on.
Yeah, because it's true. Like they even describe what protoplanetary disks are. They give a nice little summary of that. Those are the things that I look for. Is like, are there big words that people would be like, well, what's that about?
And so a lot of the time, when we're reporting on stuff, I'm looking for stories that isn't well covered. And so a good example is like, we talked about this Fermi paradox story earlier, where all it is it's a journal article, and it's, journal articles generally require someone to translate because they're written by scientists for scientists. And our job is to communicate this stuff. And so if I think this is interesting, then we will report on it and try to get the news out there in a way that's more easily digestible than what's in the journal. Click on the actual journal article and you'll see it's, a lot of math and gibberish, right?
Oh yeah, no, that's why I'm staying away from that right now, because then everybody's gonna be like, "What?"
Yeah, well, you click on the PDF. Click on the PDF over on the right-hand side there, and then you'll see the sort of like what a journal article really looks like.
Oh yeah, no, I love reading these.
Yeah, no, and for sure, and so I find that very fascinating, right?
Yeah, and we're gonna get down to some math. See, here we go, and then, well, is that the Drake equation?
Yeah.
Yeah, it is.
Yeah, so they're essentially recalculating the Drake equation.
What are your feelings on the Drake equation? Do you have any?
I don't know. For me, the Fermi paradox is so troubling that everything that the only answer, answer that I can sort of come up with is we're alone or we're first. So I personally don't think there's any aliens out there. And so this, I'm very biased. And so this paper is like a, bullseye right on my brain. And so we're absolutely going to be reporting on it.
Yeah.
But, and of course, like the people behind it, Drexler, who was sort of one of the people who popularized nano machines and things like that. So, yeah. So that's, if people want me to say what I think about, where are all the aliens, I don't think they're out there.
Oh, I don't think I've ever asked you that.
Oh, really?
No. Like, so you don't believe in aliens?
Well, I don't believe in, I definitely don't believe in UFOs.
Right. Well,
or as I say, I am unconvinced by the evidence that has been presented. And no, I don't think there's any aliens out there in space at all.
So what about us then? How do we explain us? I'm just curious. I'm not going to like debate.
Well, it's it's clearly possible for life to form in this universe. We are the evidence that the life can form.
Right.
But how often does life form? We don't know.
Right.
The whole purpose of the Drake equation was to try and help us get a measurement for how many alien civilizations there should be out there. But every single one of them is an assumption that's so vast,
right,
that it can be 0 or it can be 1 billion.
Yeah.
And you won't know which one it is until you finally have either explored every nook and cranny of the entire universe, or you have found more aliens.
Yeah. The one thing with the Drake equation that I'm pretty okay with overall is the whole in section. Let me see if I can actually make this. Yeah, right here. Is the part where it says n equals blah 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 blah, but n can never equal 0 because we exist. That's the only thing that I think is pretty cool.
Well,
about
it's
it.
just
That's
it's
as far
just saying
as I take
apart
it.
from us.
Huh?
It's just saying apart from us.
Right. I guess.
So it's not just there's us.
Right.
And then apart from us. But one sort of really interesting thing is that we know that life, that an advanced civilization can form here on Earth. And yet we seem to be the first civilization that's ever done it. So, we may not know if the conditions for life are there anywhere else in the universe, but we know that the conditions for life and for advanced life are here on Earth. And yet it looks like humans are the first ones to ever cross. Like, what are the chances that we're first? And yet we do seem to be first.
Yeah.
Blue whales are the biggest animals that ever existed. And they're here right now.
And so, I mean, so what do you think about like just the fact that we haven't really been able to go and look closely at other systems and
Well, and that's why I'm so excited about these big telescopes, right?
Right.
I mean, I just because I don't think that they're out there doesn't mean that I don't think that we shouldn't look.
Right.
We should totally look.
Right.
We should try and find them and explore the entire universe. But it's super weird that we don't see them.
Yeah, I guess, and a lot of people would be like, but I see them.
Sure.
But I don't.
And for those people, like, share your evidence. And as soon as I can hold an alien hydrospanner or take a trip on a UFO, I don't find the evidence convincing.
Right. And it's true. I mean, it is kind of, but I think that, I don't know. I go with a lot of the common, that there, of course, there's got to be if we exist. I don't know, the probability problem.
That's what this paper says. This paper says that, us being the only advanced civilization in the entire observable universe fits within potentially the probability.
Yeah. And this is talking about, a different, so a lot of people don't know the difference between, what's the word I'm looking for? What's the word? My brain's not working right now. Not just alien life forms, but this one's talking about intelligent alien life forms. So like us, as opposed to like single cell microbial amoebas. Right.
But single cell, I mean, there's a couple of events, right? So somehow you went from no life to life, right? That whole idea of abiogenesis, that happened somehow. And then you went from single-celled organisms to multicellular organisms, and that happened, and that's weird. How did that happen? We don't know if that's a common event. And then you had an intelligent species. And I think, we see intelligence enough times in octopuses and dolphins and pigs and parrots and stuff. So we can kind of see a lot of intelligence happening across, multicellular organisms. So it feels like once you get to multicellular, then some kind of advanced species seems to be a given. It's just, we just don't know how many times they've made that transition over. And it's entirely possible that it's never. I mean, like I said, when you really think about the Fermi paradox, it is such a troubling concept. It is that I have this conversation. I have this conversation with every astronomer that I've, most astronomers, anyone who's really thought about the Fermi paradox, they come to a very similar conclusion to what I'm saying. I am preaching to the choir.
Oh, really?
That. Oh, yeah. Yeah. The Fermi paradox is troubling. Yeah. Yeah.
And so again, it's just like, we should have seen it by now.
Well, yeah, it's just like, you and I are both, in the field of computers. How long do you think it's going to be until 3D manufacturing allows you to make allows a robot to go make a copy of itself from resources in the asteroid belt?
Oh, yeah. Not long at all.
Not long, 200 years.
Yeah.
Probably more like 20 years, 30 years, but, let's be safe, say 200 years.
Yeah.
And then, there are 30,000 asteroids in the solar system right now that came from other star systems. So if a dumb chunk of metal or rock can make the trip from one star to another star, we should be able to make a robot do the same thing, right?
Right.
Hide a robot in an asteroid and then have it go to another star system. So there's nothing in the laws of physics that prevents this idea of von Neumann probes, right? This idea of just like sending a robot to another world. The robot makes a bunch of copies of itself, and then it goes to other worlds. And then each time it lands, it builds monoliths, things like that. That should be possible. And yet we see no evidence. And, we're on our way to replacing ourselves with our robot overlords, right? Singularity shows up and the super intelligent artificial intelligence takes over, and then they do it. And yet we don't see that either. So, a lot of the arguments that people make about like, well, where are all the aliens? Oh, all the aliens are just on that other, they're just too far away. And so we can't find them. Yeah. You start up one of these robot factories at any part of the entire Milky Way, and it can essentially spread out to the entire place within about 10 million years. Eladriel is saying, what would be the purpose of making a robot surf? To explore. Yeah. Right? To just understand what's out there. Like we would, if you could build one robot and send it out into space, and it could then start sending data back about every other star system in the entire Milky Way, wouldn't you do that? Wouldn't that be a thing that you would want to know? But if I could hand you an envelope that had inside of it,
ever.
People would take 10 million years, which is a fraction of the billions and billions of years that the Milky Way has been around for.
True. True. When you put it to scale like that, then it does make sense. Synthetic life will rule. We will be assimilated. Resistance is futile.
Yeah, exactly. I, for one, welcome our future robot overlords. But you can travel for 70,000 years to the nearest star. Sure. Yeah. Right? Hide it in an asteroid, let it mine out the asteroid, build more copies of itself for 70,000 years, gets to the next star, finds another asteroid, builds more copies, sends asteroids. So we can imagine this technology. And so we can imagine aliens doing something else, or who knows what they'll be capable of 100 years from now, 200 years from now, 300 years from now, 1,000 years from now, 1,000,000,000 years of more advanced technology.
Yeah, and our technology's gone crazy, you know, I mean.
And yet we see no evidence whatsoever anywhere we go. And so that's really what the concept of the Fermi paradox is about. Is it's not about the fact that the Milky Way is big and intelligent civilizations can be far away. It's that civilizations should be able to colonize the entire Milky Way.
Yes.
Eventually, they should be able to colonize entire galaxies. They should be able to colonize really every galaxy that is reachable within, several billion light years.
Yeah.
So
and so Star Stuff Studios says, so basically 10 million years ago, we had some present day Earth-like civilizations did this. We'd see their robots explorers now. Like he's just kind of confirming what you're
10 million years ago, we'd see their robots buzzing around, dismantling the moon and turning it into more robots, right? And maybe not annihilating us because they're nice.
Or we're not that cool. Maybe they are limited resources and they're like, don't waste your resources. They're fine. They'll annihilate themselves.
Sure, maybe. I mean, there's this great series of books by Fred Saberhagen called the Berserkers, and the gist is you build these probes, and you just send them out to every star system to annihilate any other life forms that you find, to prevent any future, any future competitors to the resources of the galaxy.
Yeah.
So that's
really
scary.
cool. No, a lot of people are liking this because I think it's it is.
Well, and down the road, we're going to harvest more and more of the resources from our own sun, right? So we're eventually going to build this great big Dyson swarm.
Oh my God! You think we will? You think we can build a Dyson swarm?
Sure.
Really?
Yeah, absolutely. Yeah. Because we're going to want more energy, right? We're just all we're going to do is we're going to want more energy. If you track the amount of energy use that human beings have used across the entire civilization back to when we first started to use energy of any form, there is this exponential curve that you can smoothly track. And you can even then plot it out into the future. And you can predict exactly when we will have the entire energy output of our sun, that we're utilizing it. And you just do it one after, you build one solar satellite and you put it into orbit around the sun and it gathers some energy, and then you need more. And so you build a second one, and then you build a third one. And then eventually you've built a cloud of these things around the sun, and you're harvesting every single photon that's coming out of the sun. But the crazy thing is that a Dyson swarm would be easy to spot out there in the universe, right? And so astronomers have actually done surveys to look for these swarms, and they don't see them. And then sort of the next idea is you take all of the resources of your entire galaxy, and so you've essentially turned every single star in the entire galaxy into a Dyson swarm. And those would be obvious. You would see them sort of blazing in the infrared spectrum and not in the visible spectrum. So you'd see whole galaxies that are made of infrared. And astronomers have done surveys to look for both Dyson spheres, Dyson swarms, and galaxies that are entirely Dyson swarms, and they don't see them.
Okay, so a Dyson swarm is different than it's a type of Dyson sphere.
Well, a Dyson sphere is like a rigid shell, but it's sort of a ridiculous idea because you can't have the sphere hold, right?
Right.
So, right, because it's not in orbit anymore.
Right.
The second you make a rigid structure around a star or a planet or whatever, it's no longer in orbit. And so it will oscillate and bash into the star or into the planet. So like Ringworld, you remember the Ringworld series, right? Yeah, it was not stable because as soon as you build a rigid ring around it, it's no longer in orbit.
Yeah, that's what I was wondering about the building materials though. The building the
so you can take
requirement.
all of the material, you can dismantle every planet, asteroid, Kuiper belt object in the solar system, and you could build a shell 20 centimeters thick around the sun if you wanted to.
But people aren't even putting solar panels on their houses.
So this year, the United States invested more in solar energy than any year that's ever happened before. This year, solar energy is outpacing every single other kind of energy combined.
Yeah.
especially in China. So there's more solar panels coming online providing electricity than all of the natural gas, coal plants and nuclear plants combined. So this is what it looks like when you're in the middle of a transformation of energy, and the solar panels they follow Moore's law. So, they just get every couple of years, they end up being half the price. And then a couple of years later, they're half the price. Again, you're in computers. You know how this
I know
works.
all about Moore's
Right.
law. Yeah. So
Yeah. So that's what this feels like.
this is exactly what it is. I mean, we're seeing this increase, and it's crazy.
Yeah.
So who's
So as soon
to
as you turn
say?
anything into a technology, it sort of jumps onto that Moore's law bandwagon and follows the halvening of the price until everything is free and everything is covered in solar panels. So,
Yeah, and that's the thing that I've been seeing more, in Colorado, which I'm kind of surprised in Colorado why that's not more of a thing. But there's, again, the aesthetics of it. I feel like some HOAs, homeowner associations are like, well, those are ugly. And it's like, yeah, but energy.
Yeah. And they won't be ugly in the future. Pretty soon they're going to look like, well, they already can look like roof tiles.
Oh, yeah. Elon Musk
making
has
them
some,
flexible.
right?
They're going to put them into your glass. They're going to make your walls out of them.
Yes.
I'm
ready for
plant
that.
a lawn, and it's all just going to be solar panels. Maybe not that.
Not that bad, but
yeah.
I'm so ready for that.
Although it kind of is, right? Grass is a solar panel. So anyway.
It could be. You could have little blade solar panel. That'd be hell. Wait, hold on. So can you store the photons? So I'm missing a bunch of questions regarding, like, because Dyson Sphere talk, I don't really talk about because I just still in my brain am like, no. But I'm also, just a lowly computer science graduate.
Yeah, well, again, it's just an energy question, right? It's a power question. You just chart the power of humans' requirements, and it is a smooth logarithmic curve.
Right.
And then you just look at the amount of power that the sun puts out, and those lines cross at a certain date.
Mm-hmm.
And you can predict it. You could probably predict it within to the closest 100 years when we will be using all of the solar energy from the sun.
Yeah.
And then, the speed of light is the problem to get all of the power in the entire Milky Way. But, taking the speed of light into account, you can also predict that. So, and you don't have to know how it's going to happen. You just have to know that it's going to happen. Or for some reason, we're fundamentally not going to want energy in the future. Maybe, but, or something really bad is going to happen to us, which is, a whole other conversation.
Yeah.
So that's it. So for me,
I'm just reading the chat. There's interesting, like, everybody's obviously being very, they're interested, because I think this is an interesting part that I really can't offer them. So it's really, it's nice to have somebody that, I know that they definitely appreciate being able to, like, ask questions about things, because I usually just shut this down and then people are like, she's mean.
You're mean.
You're so
Why don't
mean.
you talk about Dyson spheres and swarms
and Drake equation
and the great filter?
The great filter. And yes, let's talk about, because I usually don't at all, because again, there's some ideas. Wait, Felmal said something. Even Dubai oil capital is investing in solar.
Yeah.
Oh.
I mean, what a great place to run. Yeah, they got a new solar installation, I think in Dubai, at just like or in Saudi Arabia, for like the most ludicrously cheap per kilowatt hour prices. Like, it was just some ridiculous amount. Like, we are deep into the solar, and now anyone who really fights it, and this is the cure for climate change, we hope,
right,
is that now it's ridiculous to not, like, we're now seeing coal plants canceled. We're seeing nuclear plants canceled because they're just not competitive to solar factories, and the prices just keep coming down. It's ridiculous. Yeah. Which is great. Like, that is the path out of climate change, is that we're going to get these really inexpensive solar panels that are going to sort of drag us into a renewable future.
Yeah. And all hail the great filter. Question, would it be possible to float millions of photocells in the polar regions to collect the aurora effect energy?
No, because when you see auroras, you're seeing charged particles
Right.
coming from the sun, and they're going through the atmosphere, and they're ionizing and blasting out photons of light, but they're getting sort of captured and trapped by the magnetosphere. So maybe you could get like a little bit of energy from the Earth's magnetic field, but really, like, just use solar panels. Like, that's where the power is. You're getting whatever it is, 1,000 watts per square meter, or 1,100 watts. So you want solar panels.
Someone just changed something, and just let me know if you need to go and be like, I need to wrap up in 10 or something. Are you?
Yeah, I need to wrap up in 10.
Okay, perfect.
Or we can go till 2, and then I got to wrap.
Okay.
I think.
Well, if you want to do 10 just to be safe, that's fine. We can just do this for another 10 minutes.
Yeah, let's go till 2.
Okay.
Yeah, and then an hour, because we're gonna do this again next week, right?
Yep.
Yeah, so we'll just go for an hour.
Okay.
That's and that way we can sort of focus it and
yeah. So he's now a regular on here, guys. But there's just so much interesting stuff that, and I would definitely have this more focused, but I'm a little bit more casual with you, like I am with Dr. Pamela. But
you'll learn to be more casual with Pamela.
Yeah, no, she's like, she'll be on here, and I can have her on for a few hours and she's fine. Someone said, could we talk about pulsars and how we could use them as our GPS navigation positioning in place of satellites in space? Yeah,
yeah, that's actually sort of, I've got 4 episodes of the Guide to Space that I'm working on right now, and one of them is going to be about space-based navigation systems and sort of the different ways that they're going to be able to do that. And so one of the really cool ideas is using pulsars as a way to navigate in space, because pulsars give off a very predictable pulse of radio waves. And so as you're moving through the solar system, you can actually then detect the delays from the different pulsars, detect the Doppler shift, and know kind of where you are and where you're moving. And so NASA has demonstrated that you can essentially make a pulsar navigation system that would work within the solar system. So a spacecraft is anywhere around the solar system, looks for all these known pulsars, and can figure out where it is and how fast it's moving. And you can imagine that being rolled out into a Milky Way wide navigation system. So wherever you are, you look for pulsars, you can tell where you are in the galaxy and where you're moving, and be able to navigate. So that's all I know right now, but I will know much more once I've finished researching and doing my episode.
Yeah. And there is, I'm just trying to look through some of these questions. How about blazars? Blazars.
Yeah, blazars are just another kind of supermassive black hole. It's another kind of quasar. So back in the day, when astronomers first found quasars, they didn't know what they were. They thought they were, they called them quasi-stellar objects, and they were these really bright point-sized objects that were blasting out radiation. And then they found these other objects which were giving out a different kind of radiation, and then they found these ones that were giving out radio emissions. And what it turned out is that what it is the perspective that you're seeing as you're looking at the quasar. And so if you're looking straight down the jets, you're seeing a quasar, but if it's at a bit of an angle, I think that's the blazar. And then if you're seeing it from the side, where there's this sort of gas dust disk around the black hole, then you're seeing the radio emissions. And so that is less, it's the same object, just seen from different perspectives. And so astronomers in the last couple of decades have been able to merge all of these things together into one, and to know that it's one object.
Aloha Joe Radio says, should we expect the biggest hurricane season in mankind this year?
I really hope not, because I'm going to be on a cruise with Dr. Paul Sutter and 50 of our closest friends in September. So I really hope that it's not.
Yeah, because that's right around the time too. Like the August, September, not good months. I mean, it's already kicked up hurricane season right now, but a blazar, never heard of it.
Yeah. Anything special about a black hole that doesn't spin? Well, it's more like there's things that are special about black holes that do spin, right? And that all black holes are going to spin. So the chances of a non-spinning black hole is, and I guess the math gets easier. Again, that's more of a Dr. Paul Sutter question than me. But one of the things that's pretty fascinating is as you take a black hole and you spin it up faster and faster and faster, the limit that it can spin is essentially the speed of relativity. It can only it'll spin up until it's getting to a point where, you know, the speed of light prevents it from going any faster. And as it spins up, the event horizon flattens out on the black hole to more like a donut, but you can never get the singularity to be revealed because of the limits of relativity. And you can tell which way a black hole is spinning by the distance between the black hole's event horizon and the accretion disk. And so if the black hole is going in one direction compared to the accretion disk, you can see sort of a bigger gap. And then if it's going in the other direction.
Yeah.
So.
And I believe we actually get the radius of, well, at least stellar black holes, which do seem to have, you know, faster spin than supermassive. I think it's we calculate.
Well, the supermassive black holes that have been found spinning at close to the speed of light.
Yeah.
Like 70% the speed of light.
But we're finding these ones that are, let's see. I think it was in the case of M33X7. So that one has a crazy spin. But and also the radius of that would be dependent upon, I think, their mass and also their spin, right? That's how we would get the radius of a.
But it's sort of like it's the same thing when you think about it, that, you know, you can't move through space faster than the speed of light, and you can't spin in space faster than the speed of light, right?
Yeah. Is it true?
Relativity prevents it.
Is it true that China's planning or actually building their own version of CERN?
Well, they have.
Yeah.
They already have their own particle accelerators.
Yeah.
So is it, Starbuck is asking, is it the relativistic speed of the supermassive black holes that gives them the mass? No, it's just the amount of stuff in them.
Yeah. Yeah, I have a bunch of notes that I've taken on things like that to understand, because there's big differences between, you know, like a supermassive black hole and a stellar black hole, and then they have these intermediate black holes that are purely hypothetical at this point, but and we're finding out a lot of things. A lot of the cool news that's been coming out that we talk on here is about that kind of stuff. But then you can get into really crazy. I think someone asked somebody was talking about if one black hole, you know, collided with this black hole in this way and this way, and
so is that what you do? Like you get these questions and then you do research afterwards, try and add more and more material into your brain.
Yeah, I tried to take some questions, like, because some people actually do bring up good questions that are pretty difficult to research over time. Yeah. And, you know, the things that we talk about are mostly the basic things, and try to make sure that people understand, like,
but it's interesting to sort of, I mean, with the amount of stuff that I do live, I mean, I don't have a Twitch channel that I spend a lot of time on, but, you know, what we do over on YouTube and stuff, it's like answering questions like this really helps you understand the material and makes you a much better science communicator. So
totally does.
You know, I think I want to speak for all of your viewers when I say thank you for taking all this time that you do to sit here and interact with people and share the science and share this community. You're doing a fantastic job.
And hopefully thank you. I appreciate that.
And I know that it's
tough.
hard.
It's
you know, we're what, an hour and 45 minutes and I'm exhausted.
I know.
So
and
I don't know how you get this rolling day after day after day.
Yeah. Yeah. And and you know, again, like it's a balance I have yet to figure out too. I always think I have it and I'm like, yes, those are amazing space streams. Like I did one that was 9 hours last week.
Yeah. And
then I just, you know, I have to work in something else because I do go crazy by it.
Yeah. Yes. I mean, that's the key, is figuring out your limits and the amount of energy that you can bring to it.
Yeah.
You know?
Why is lead such an effective radiation shield material?
protons. You want a lot of protons. And that's why water is good too. A lot of protons in water.
That was an easy one. Could the next phase transition change the law of physics?
Which phase transition? Are you talking about like 0 point energy? I think it is.
Oh God.
You've heard, again, that's a Paul. That's a Dr. Paul.
I'm like, that's an Ethan Siegel.
Yeah. Well, the gist is that, you know, and I'm going to mangle this, and I apologize in advance.
It's fine. I do it all the time.
But yeah, that essentially the quantum state that the universe is in is not potentially the lowest state that it can be.
Mm-hmm.
So there's mathematically a lower state that everything can be in. And so you could have this vacuum energy. You'd have this moment where some portion of the universe collapses into this lower state, and then sort of everything destroys the universe from that point, expanding at the speed of light, because you would have new laws of physics that are incompatible with our existing laws of physics. Vacuum decay, that's what it's called.
Right.
Vacuum decay. Yeah. Someone's saying, 0 point energy is from Stargate. That's exactly right. You know, with your Nakata reactor. So, it's called vacuum decay. So ask Dr. Paul all about vacuum decay.
Oh my goodness.
Someone write that down.
Yeah, no.
And then next time he's on.
We all need to be, because I don't have my pen around here. But one thing I wanted to talk about, though, because I was curious. Wait, is my pen back here? No, I don't know where my pen is.
Here, I got one.
Thank you. I wish that really worked that way. Why can't that work that way?
Someone wanted to know what my planet posters are. I've got one for all of the planets, and then a bunch on that I rotate them, although I haven't rotated them recently.
Except you have Pluto.
Mm-hmm. Exactly. One for all of the planets.
Word documents. No, you guys are going to have to help me remember all these things. I don't remember like half the things. I need to ask Dr. Paul. Wait, do gravitational waves occur only as pulsars from massive events, or do they occur everywhere always?
You are okay. So I like this. Is your answer hypothesis, thesis, or by evidence? So let me see. So Einstein predicted that any mass that moves will generate gravitational waves, ripples in space-time as they move, as essentially space-time bounces back as masses move through it. So that was the prediction. And so you will get that when black holes move, you'll get that when neutron stars collide, and you'll get that when anyone moves. And then astronomers set about spending the next 100 years trying to find evidence that matched his prediction. And now there have been the discoveries of these massive gravitational waves coming from colliding black holes, which are sort of like the most extreme events in the universe. They've finally been able to detect the gravitational waves. And as they build more sensitive gravitational waves detectors, they are expecting to find gravitational waves from less extreme events. So assuming that Einstein is still right, then as you walk around, you are emanating gravitational waves.
Yes. And so that's the thing that we were talking about with Lisa. Having an observatory out in space would be great and wonderful, because then we can pick up on, because even with those two neutron stars colliding, you know, they're both not as massive as a black holes colliding, but you know, it was incredible that we could detect that. That was pretty sweet. Observatory in the moon. I don't think we want in the moon,
of the moon,
around the moon.
Yeah.
And let's see here. So move it, wave it. So let's, someone else said black hole is entrance, white hole is exit to another universe. Simple enough. No.
The way I always like to describe a black hole is it's kind of like a wood chipper.
Go on.
So what is on the other side of a wood chipper? But that's not really a great example. Trash compactor. Actually, that's a better one. What is on the other side of a trash compactor? Jump in and find out.
I don't want to.
No, you don't want to.
I don't want to.
And here's a great thing that's funny is like, you just think about, okay, so like jump off of a chair onto the ground, and you will feel the effect of gravity, of one Earth's gravity. Now jump off of a building, and you will feel that one Earth's gravity.
For maybe
now
not
jump
even a
off
second.
of a building. What's that?
I said not even for a second.
Yeah, not even for a second. Now jump off of a building on a white dwarf where the force of gravity is thousands of times the force of gravity on Earth, right? Would you be willing to do that? Right? You know, if it's pain to jump off a building here, it'd be mega pain to jump off the building on a white dwarf. Well, a black hole, you know, then now try a neutron star where the force of gravity is hundreds of thousands, right? A black hole is just the next step above a neutron star. It's just a neutron star that got a little more massive, and so now the force of gravity is even stronger. It is not a portal to a spiritual awakening. It is a incredibly dense gravitational well, and it's a thing that if you jumped off onto, you would go squish and you would be added to the singularity of the black hole. So.
It would hurt less to jump off a building on a white dwarf because you wouldn't
you wouldn't have time to feel it or think about it.
Yeah.
And buildings couldn't exist because the immense gravity would just squish them into
It would just be like a
a 1 atom thick fluid.
I would not
around
want
the
to
white
live
dwarf.
in that. No, thank you.
Yeah. So, you know, that's the thing is that when people say, like, you know, what's on the other side of a black hole?
Yeah.
It is what is on the other side of a trash compactor.
I'm listening to Fraser and I'm jumping off a building while Lottie. Joe's like, be right back. I'm going to go test this. Yeah, you wouldn't even make it to the ground. On the topic of dive bombing a black hole, given the time dilation involved, would you die of old age before being crushed by the gravity?
No, it's a perspective thing.
Right.
So anyone watching you jump into the black hole would die of old age, and would get really bored of your journey to your death, but you would experience it in real time.
I get really bored watching Fraser fall into that black hole.
Right.
At some point, he's just going to appear that he's stuck there, not even moving.
And then fade away.
Yeah.
The wavelengths are getting so stretched out.
And then
again,
from
these
his
are Dr.
perspective-
Paul questions.
Yeah, these are time dilation stuff.
Yeah. And Pamela.
And Pamela, I'm okay with handling some of it, but then there's always one person that wants to take it like another step further, and I'm like, and that's when I say I don't know. I'm getting comfortable with saying I don't know.
Yeah,
Getting very comfortable with saying I don't know.
I mean, there's a couple of parts to it, right? Like again, like you can kind of see this journey that you make, and sort of in the beginning, you think you know the answer to a level of specificity, and then people slap you. You know, the people who are watching your video and you know, they'll give you a slap and go, no, the universe isn't 13.8 billion years across. That's actually the co-moving distance, and it's actually 46 billion light years across,
right,
etc. Right.
Yeah.
And so you make those mistakes, and every time, you know, you get zapped by the people who are watching you, and you eventually get better and better at giving your answers and learning from your mistakes. So
it is true.
Don't feel bad. You're doing, again, I reiterate, you're doing a great job. And
it's a lot of numbers.
It is a lot of numbers to cram into your brain, but you just keep doing it 9 hours at a time. 9
hours.
And it will all make its way into your head eventually.
I don't think that. I think that was a rare thing. I used to be able to do it longer. Like I think I found that I can't do these really long streams, but if I'm going to do this solely, but you know.
Yeah. I have a plan. Well, you see the telescope behind me. I've got another telescope that I'm going to be working with tonight, actually, and we're going to be able to do some live telescope viewing with the telescope. And so in March, I want to do a Messier marathon where we see every single one of Messier's objects in one night, and it takes about 10, 12 hours to do. So
are you still how's getting the virtual star parties?
Virtual star parties? Well, right. So it's been harder than I thought. And it's all thanks to Oceanside Photo and Telescope. I'm wearing their shirt right now. That's one of their telescopes behind me. And so the guy who runs Oceanside Photo and Telescope is has built a bunch of remote observatories that are all controllable by on computer. And so I can access the telescope, show pictures from the telescope, and then just move to different objects in the night sky and show people. But the challenge has been, my demand is a telescope that's super different from what anyone else normally does. Because normally when you have a telescope, you want something that takes images for 45 minutes or an hour. And that's a very boring show. So the plan is that he's built this very special telescope that is big, but has a color camera on it, so it will produce images. And so he's done some tests and produced some great views of galaxies and clusters and things like that in about 2 minutes, 1 minute. So the plan is that I'll be able to kind of move around the sky and see almost anything in a way that doesn't bore people to death. So when we've got it set up, I will bring the telescope to this hangout, and we will go we'll go observe in the night sky if you want.
That would be so amazing, because I can't, all mine are manual. And I don't want to be running up and down the stairs or being like, "Hey roommate, help me out," because
okay, move it a little to the left.
That's kind of what we did with the solar eclipse. Like, he had to help me, get things, because again, we have it. It's all.
No. Hey, Google, stop.
Alexa. I miss We're about to land. This happens all the time with my Alexa. Starts doing things. He's dying. Yes.
That's awesome.
I've had that happen so many times with mine.
I know. It's like watching TV, and it just
it triggers. It goes off of something. Yeah. And then you're like, well, I would have never listened to this ever. That just,
and there you go. Now your whole stream has gotten a copyright strike.
Right. And on top of that, that's fine. And then there's, you're now, what I'd be more worried about is the big data portion of that. That just went in on your name.
Yeah.
I'm kidding.
I wonder, have you ever done that? Like, you watch a show and then Google triggers, and then you try to reverse engineer what got said.
Yeah.
That triggered Google. And so there'll be something on the television, and then she'll go like, "I don't understand." And then you're like, and then you'll try to re-say the words, what was just said on the show.
Mm-hmm.
Yeah.
No, it actually happens to me. Like, I'll be talking about something and I'll say, I won't even say anything that sounds like Alexa. And then she'll start talking about something, and I'm like, what word brought that about? Where she's like, I don't understand what you were saying. Yeah. It's really, really weird. 10 out of 10, this is scripted. Absolutely.
Yeah. My face is moving away, red shifted. Yeah. Yeah. A little embarrassing to have my Google go off.
Oh, no, that's fine.
In the middle of the live stream.
No, it's
well, I think we'll reach the end of this hour. Yes. 2 hours, actually.
So thank you so much for hanging out, guys. He's going to be here on Thursdays, not for 2 hours every time unless he has the time, which I appreciate you giving today.
I guarantee that I will not have the time, but I definitely can provide the hour. And I'm going to post my next question show on my YouTube channel in as long as it takes YouTube to digest and process the video. So in about in the next hour or so.
Yeah, and we're gonna go watch some of your stuff too, and we'll talk about stuff.
Yeah, I'm not done. Really liked the one that we just did about the super telescope. So enjoy.
Yeah, I think that's the one we're gonna go watch. So thank you so much. I'll talk to you soon.
All right. Great to hang out with you. Thanks, everyone.
Bye. Let's see.